Welcome to the second part of our gentle introduction to the C programming language. I'm Paulo Ariano and this is Pointers. So let's continue our journey exploring the C language. Like the previous episode, my recommendation is that you read the corresponding chapters in the MagPi magazine, see the examples I'm presenting. These are concepts that you really have to grasp. Programming is hard. You are not dumb. All you need is some dedication. So do not skip ahead. And please retype these examples, run them yourself, and learn by trying to do stuff. For instance, if I'm showing you a cycle that counts from 1 to 10, make it count backwards. Make it skip pair numbers. If you repeat the exercises, if you code yourself, programming will become easier. Practice is key. It's everything. One other note, people learn at a much better rate if they're well rested. So my advice is sleep well and try this stuff early in the morning. And no, coffee is not a replacement for a good night's sleep. Take your own time, do it at your own pace, but do not skip ahead. In chapter 4, you will learn about switch statements. Basically, another way of doing the if-then-else statements. On your left, you got the previous way of doing it. On your right, you got the new way of doing it. This is not particularly hard. Instead of having if something equals something, do something else, if something equals something, do something else, for every other cases that doesn't equal neither the first nor the second case, do one last thing. And then the output is below. On your right, you have exactly the same thing with a different syntax. Basically, switch, you name the variable which will affect the switch. Case, it's a value 10, it's a certain value. Do something, and then break. Break means go ahead and try the next case. Case 1, exactly the same thing, print something, break. The default is print something. This is exactly the same as the else condition in your left example. So, since this was pretty simple, I decided to show you something else. You have a for loop. The for loop is different from the while loop that you have seen in previous lessons. The syntax is really weird at first for people to read, but basically it's really simple. Define a variable and give it a default value. Then decide when the condition ends. And afterwards decide how each step is done. For instance, we start with a equaling 1. We will stop this if a is higher than 10. Basically, while this condition is true, the for loop will go ahead. Meaning, while a is less or equal to 10, we will do another run in the for loop. Afterwards, we have the increments. Right now, what I'm doing is telling him increment a by 1. This syntax is new for you, but it's exactly the same thing as a equal a plus 1. It will work exactly the same way. Yet another way to do it is a plus equal 1. It's exactly the same thing. We could change this for instance, for a minus equal 1, which would mean the same as a equal a minus 1. And we can change this number to any other number. A plus equal 2 or a plus equals 3, something like that. 3 ways of expressing yourself to the machine that the machine will get. And remember, programming is all about telling the machine exactly what you want it to do. In this chapter, you also learn about endless loops. Endless loops, either using the for syntax or the while loops, are pretty easy to understand. Basically, you set up a condition that equals true to the computer. So the loop will run forever. How do you break out of them? Well, using the break statement, like you do in the switch conditions evaluation. Using break makes the computer jump out of the loop as soon as it runs that instruction. You have 2 examples here, giving exactly the same output as the previous examples. You have one for the for loop and one for the while loop. Please study them, understand when it breaks out of the loop, and please try something. change something in the program, try and use them. Chapter 5, pointers. This is one of those things that scares the hell out of many programmers using C. There's no good reason for it because you only have to use pointers if you really need them, and you can use them in a controlled manner. So relax, learn, try stuff. There's no reason to be scared. Assuming you read the article on the magazine already, this should be pretty easy to understand. In the start of the program, I define two values. My value, which equals 5, and other value that equals 10. Afterwards, I define two pointers. PTR, my value, that points to my value, and PTR, other value, that points to other value. Notice the syntax: to make something equal, a pointer to a variable. We use that AND symbol before the name of the variable. This means I'm pointing to this object. Whatever the variable is, I'm pointing to it. And then I'm going to show you an example of how to use an asterisk to know the content of a pointer. Basically, I'm using my pointer variable, but appending an asterisk to it, which means show me what's pointed by this pointer. What value is pointed by this pointer? Then I'll give you 3 examples. These are meant as an exercise. Look at them, study them, try to predict the result, and understand why the result is this one. And afterwards, you can run the example and you'll get an output just like this one. This is pretty much all you really need to know about pointers. How to use them, when to use them, why they exist is something that we'll see yet today in the following chapters. Chapter 6, functions. Using functions, we are right now reproducing exactly the same example that we used in the previous chapter. But this time our code is divided in simpler pieces. Study the code, watch how I define the functions on top, and watch how I use them here in these simple lines. This makes stuff like repeating certain cycles of some program way easier. You just call whatever code handles that cycle. In chapter 7, you're learning about arrays and strings. Read the article and then look at this example of code. Here are 2 examples of how to declare strings based on an array of chars without initializing them, meaning I'm telling the computer allocate 10 bytes of memory, but don't do anything to it. So any random garbage that's on that piece of memory will be passed to your program. As you can guess, there can be some unpredictable characters there. So it's important that you write something to it before reading from it. In the second example, I'm allocating the B string, again with 10 bytes in memory, but this time I'm initializing it. I'm writing to it the word world. In the third and fourth lines, I'm doing this exactly the same thing, but with numbers this time. So it's an array of numbers. The first one, called some number, holds 3 values, and it's not initialized. Again, whatever it's in the computer memory on that location will be the content. It's very important that you initialize it before reading from it. On the second example, called more numbers, again with 3 elements, I'm immediately in the same line initializing the values by placing 4, 5, and 6 on the 3 slots. Afterwards, I'm showing you an example of how to initialize your array, the first one, the one that was not initialized in the declaration line. And I'm putting there 3 values, 1, 2, and 3. There are some curious things about this that you must pay attention to. Arrays start with 0. So the first slot of the array is the 0 slot. The second slot is the number 1 slot. The third slot is the number 2 slot. This can create havoc and confusion if you're not expecting it. So Remember, arrays are zero-based. They start at 0, not at 1. So, in each of these 3 lines, I'm picking up a slot and placing a number there. I could have done exactly the same thing with the A-string array that I have declared in the beginning of the program, but did not initialized. And it would look somewhat like this. In position 0, I would write H. In position 1, I would write E. In position 2, I would write L. In position 3, I would write L. In position 4, I would write O. And in position 5, I would place a 0. This is because internally, strings in C are null terminated. They always terminate with the character 0. This is really important. And if you're going to do this manually, you have to remember to place the 0 character at the end of each string. So we're using 6 positions to write hello, which takes 5 letters. But there's a better way to do it. We can use a function called sprintf, which allows us to give the destination pointer of the array. We're talking about pointers again. And place a certain string there. What does this mean exactly? Well, arrays are just a bunch of memory locations stuck together. So we can address that space in memory by using a pointer to it, to copy a string to it. You just have to be careful, because if you write further along than the memory that you have allocated, you will run into trouble really fast. And afterwards, I'm printing the result. And the result is something like hello world 1, 2, 3, 4, 5, 6. And that's it. Once again, study the example carefully, because you'll learn a lot from it. This time, like pretty much in the previous examples, what's in the comments is as important as the lines of code. So study the comments. And by the way, using comments is always a great idea. Use them wisely, they will serve you well. And that's pretty much it for this second part of the tutorial. In the third part, we're going to skip a couple of chapters that are in the original magazine that we are following. And we're going to skip them for 2 reasons. First, they do not apply to the first game that we're going to do together. They are talking about stuff like collecting user input, but they are talking about collecting it from the command line. And that's not really interesting if you're going to collect user input based on joystick movement or keys pressed inside a game or at a canvas or touch in a mobile device. So we're going to skip that chapter. And the same applies to another chapter where they will present you with the strings library that will actually help you to manipulate strings, that kind of stuff. You should read those chapters. I'm not going to cover them, but as a general knowledge and as a way to improve yourself in the language, go right ahead and study them. What we're going to do in the next video is skip those chapters and install a graphics engine, a game engine. It's called Raylib. It's the simplest and one of the best engines available for C and C++. And we're going to make stuff appear on screen, windows open, detect collisions, that kind of stuff. So we're going to trade following the magazine for some arcade action. It's a fair trade. See you in the next video.